Hi, this is our queuing theory project for QMT342 and we decided to do Tealive. So our Tealive is located in Petronas Dewangsa. It opens daily from 10 a.m. to 10 p.m. and for the system, this is a single server system with single phase system. This is the Tealive experience.
Next, we will go through the characteristics of queuing. For arrival characteristics, size of the calling population is infinite, which means there are no specific amount of customers that can queuing for the service. Furthermore, pattern of arrivals at the system by Poisson distribution or mu, there are 10 customers per hour waiting on the line for the service. And for the behavior of the arrival, the customers are patient and willing to wait for their turn to get the service. For the waiting line characteristics, the length of the line is infinite, which means there are no limited amount of customers that can wait for the queue. Moreover, the queue disciplines is first in, first out, which means the customer will be served accordingly by the time that they arrive to the shop.
The service facility characteristics. The configuration of the service system shows that Tealive has a single channel system with one server and single phase system because you buy the drink and get the drink at the same place, and the pattern of service times is 12 customers per hour, which means one customer will spend 5 minutes in the system and it follows an exponential distribution.
2.4 Basic Queuing System Configuration. To classify the queuing system, we have to look at the total numbers of channels and the total numbers of phrases in the system. For our project, we are observing Tealive. The basic queuing system configuration is single channel, single phrase system. To elaborate, the customer will be arrive and queue up to make some purchases, and then they will making a payment while they're being served by the cashier. As you can see for the figure, there are customer will be arrive and queue up in the service system. They will queue up to the service facility to make their orders, making payment, and pick up the order and be served by serve unit, which is the cashier, before they left the store. 2.5 queuing model says Tealive using single channel, single phrase system. We are using single channel queuing model. The number of arrival is 10 customer per hour, which is our lambda, followed by Poisson distribution. And the service rate is 12 customer per hour, which is our mu, follow exponential distribution. Firstly, we are calculating the probability that no customer in queue system. There are 0.1667 probability of no customer in the system. Next, we are calculating the number of customers in the system, which is L. For the result, there are 5 customers on average in the queuing system. In addition, the number of customers in the queue, which is LQ. For the result, there are 4 customers on average are in waiting line. Moreover, we are calculating time a customer spend waiting in the system, which is W. For the result, there are 0.5 hours, equivalent 30 minutes, on average in the system per customer. Furthermore, we are calculating the time a customer spend waiting in the queue, which is WQ. For the result, there are 0.4167 hours, equivalent 25 hours, on average time in waiting line per customer. Besides that, we are calculating the probability of server busy. For the result, there are 0.8333 probability that the server will be busy. And the last but not least, we are calculating the probability of server ideal. For the result, there are 0.1667 probability of server is ideal.
And finally, we have the conclusion and result. The first question is the number of servers provided adequate? The answer is yes, because the number of customers that comes to buy the product on average is not big. One server is adequate and suitable for the system. The second question is, are the customers happy with the waiting time? From my observation, the customers are okay with the waiting time because they are attended accordingly and fast. And lastly, from this project, we can describe that it was a good learning experience as we get to understand the queuing system configuration, and we were able to explore Tealive's waiting line queuing performance in real life with the knowledge that we have learned throughout the whole semester about this subject. Overall, it was a fun experience for each of us, and we are interested to find more about the queuing theory from other stores. That is all from us. Thank you.